Now for this question, it is given that the equation x cubed minus 21x squared plus kx minus 216 is equal to 0, where k is a constant, has real roots a, ar, and a to the r minus 1. Find the numerical values of the roots. Now first of all, we need to realize that the roots are x is equal to alpha, x is equal to beta, and x is equal to gamma. And if we take the product of the roots alpha, beta, and gamma, we should be able to get negative 216. So where do we go from here? So these are the roots, therefore we got a times ar times ar to the minus 1 is equal to 216. A times a times a is a cube, r to the 1 times r to the minus 1 is r to the power of 0, and all of that should be equal to 216. Minus minus becomes plus, so a cube is 216, and therefore we know that a is going to be equal to this cube root of 216, giving a as let's check it out here, 216, we should be able to get 6. Alright, so here we are. Now that is going to help us to find the numerical values of the roots. Now, how do we do that? Now we're going to take the sum of the roots, and we know that the sum of the roots is 21. So what we're going to do, we're going to say a plus ar plus ar to the minus 1 is equal to 21. And from here, what is a? A is 6. We can factorize a outside. We've got a as 6 here, so we put 6, and then we have got 1 plus r plus 1 over r is equal to 21. 1 over r is r power minus 1. So if we, r times 1 is r times r is r squared plus 1, and then we have 21 divided by 6. And the r can go on the other side as well. So from here, we've got, so 6 times r is 6 r squared. Well, I'm sending the 6 back there again. So what we can do is, let's take 21 over 6. So 7 over 2. So I've got then r squared plus r plus 1 is equal to 7 over 2r. So that's 2r squared plus 2r plus 1 is equal to 7r. So 2r squared, 2r minus 7r is minus 5r plus 1, is that 1? So if, 2 times 1 is 2. So plus 2 is equal to 0. So if we factorize this, we should be able to get 2r, and then r, 2, 1, and here we are. So yes, so r is going to be equal to half, and r is going to be equal to 2. Now from here, we're going to find the roots of the equations. Okay, the roots are a, ar, and r power minus 1. We can take r as 2, you can take r as half. It doesn't matter which one you take. So we're going to take a as 6, therefore 6 times half is the first roots, or first root, maybe alpha, beta can be equal to ar, alright, a, which is then 6, I can say gamma is equal to a, which is then 6 times, we took r as 2, so that's going to be 1 over 2. Because if r is 2, we have 2 to the power minus 1, which is 1 over 2. 2 power minus 1 because r power minus 1. So this is going to give us 3. So the roots are then, oh well, what about, well, I took half, and I'm confusing myself here. So half, okay, times 6 is ar. Then this is 6, which is then this is alpha is 3, beta is 6, gamma should be equal to, this is, oh right, okay, here we are. So what we are saying then, 6 divided by half. If you take 6 over half, you are going to get 12. So the roots are then 3, 6 and 12. So here we are for the first part of the question. Now in the second part of the question we need to deduce the value of k, that is this value here. We're going to use the roots. So we have x minus 3, x minus 6, x minus 12. If I multiply all these out, I'm going to get x squared minus 3x minus 6x minus 9x plus 18. And all of that should be multiplied by x minus 12, 0. So we got then x cubed minus 12, x squared minus 9, x squared plus 108, x, 18x, and then 18 times minus 12 is minus 216. All of that should be equal to 0. Simplifying all of that, we should be able to get this plus that is plus 126, x minus 216 is equal to 0. If we compare this to our original equation there, that is this one here, we're going to see that clearly kx, alright, is equal to 126x. Therefore the value of k has been deduced to be 126. And here we are for the second part to this question. Take care.